Hello and welcome to this video lecture series on microwave tubes. In this video, we will talk about very important microwave tube which is used as a broadband microwave amplifier is traveling wave tube amplifier. Traveling wave tube, and it is used as amplifier. So in short, it is called as TWTA. So it is very much required whenever we have a broadband application. We should consider this particular tube because it is used to generate or you can say used to amplify a microwave signal or broadband range of frequencies. Because of its broadband performance, these traveling wave tube amplifiers are generally used as the last block of amplifiers in satellites, that is high power amplifier. So most of the satellites, they use traveling wave tubes as the high power amplifier. So now we will try to understand how broadband operation can be achieved and what is the importance of this traveling wave tube amplifier. By the time we have discussed about two cavity klystron amplifier, we have also discussed about multi-cavity kind of a thing, multi-cavity klystron amplifier. We also talked about reflex klystron, which is actually a microwave oscillator. So if we have a requirement of high gain, what we do, we shift our two cavity klystron amplifier to multi cavity klystron so that it would result into high gain kind of a microwave amplifier. So further, if we have the requirement of high bandwidth, or rather we can say broadband kind of a response, if we have a requirement of broadband high gain kind of a microwave amplifier, if we wanted to design, so what is the problem with this two cavity is that in this two cavity case, if you remember, we have also discussed about the gain bandwidth product limitation. As the operating frequency would be increased for any resonant circuit, their reactive elements such as inductance and capacitances must be decreased in order to maintain resonance at operating frequency. And because of the gain bandwidth product limitation, we know that we could get the higher gain at the expense of narrower bandwidth, and that is because of the limitation of gain bandwidth, or in other words, we have inverse relation between gain and bandwidth, which we have discussed at the start of our maybe second video lecture in the series of microwave tubes. So since we have been using these resonant structures for two cavity or multi cavity, it is not possible to obtain the broadband response at the microwave frequency. So there are different ways to get the broadband response. So we can use the several non-resonant periodic structures can be used to obtain the broadband response. So at the start, we understood these traveling wave tube amplifiers are basically used for broadband high gain microwave amplification purposes. There are other types of traveling wave tube amplifiers, or maybe based on the used to call it as a slow wave structures to get the broadband response. There are different types of traveling wave tube amplifiers, but the helical traveling wave tube amplifier, wherein we use the helical structure or helical lines of a slow wave structure, is used to design the traveling wave tube so that it would slow down, because the wave electromagnetic wave or RF signal is going to travel down this particular helical structure, so it would require more time. So the maximum amount of interaction of the axial electric field, which is rather generated because of the movement of RF signal through this helical structure, and electron beams, those who are traveling down the tube, that interaction will be taken place for longer time. So it results into the higher bunch of electrons, and electron will transfer their kinetic energy to the electromagnetic field which is actually traveling down the tube. So that is the purpose why we use slow wave structures. So as I said, there are different types of slow wave structures, out of which if you use helical structure, so that TWTA is called as HTWTA. HTWTA, helix traveling wave tube amplifier, which is very very popular. Again, we have a type called as coupled cavity traveling wave tube amplifier. So in this particular type of TWTA, what happens, as we know that in case of a multi-cavity klystron or even two cavity klystron, each cavities are independently tuned, but in this case the all cavities are coupled. That is why the name coupled cavity traveling wave tube amplifier, and because of that, very high or average amount of output power can be amplified with the help of this structure, and they are very much useful in the case of radar transmitters, because in case of radars we require very high amount of a power, so that can be done with the help of coupled cavity traveling wave tube amplifier. So this is about the requirement of or the significance why we use traveling wave tube amplifier microwave tubes. So broadband response and high gain. And how do we achieve it? We use the different slow wave structures so that more interaction between RF signal and electron beams would be taken place through the tube. And we have different slow wave structures such as folded line. Helical line is the first one. Second one is a folded back. Third one is a zigzag line. Then fourth one is a interdigital, and fifth one is a corrugated waveguide kind of a structure. So out of which we will discuss about the first one, which is a helical traveling wave tube amplifier, which is generally used. Before we discuss about details of this traveling wave tube amplifier, since we have discussed about reflex klystron, two cavity klystron, it is customary to compare some important points, or let us differentiate between klystron tubes and traveling wave tube. So first point of discussion, if we see as difference between traveling wave tubes and klystron. We know that these traveling wave tubes have been invented by Conchner and klystron. First klystron tube was invented by Varian brothers. So what is the difference between them? In case of traveling wave tube, in both the cases there is interaction between RF signal and electron beam. So in case of traveling wave tube, interaction of electron beam and RF field is continuous. Throughout the length of tube, RF signal and electron beams will keep interacting, but in case of klystron tubes such as two cavity or reflex, the interaction between electron beam and RF field is restricted to the cavity itself. So that is the first point one has to understand about the difference between klystron and TWT, and that is the reason the more amount of a time electron beam interact with the RF field, it is expected that electrons will give up their kinetic energy to the EM energy during their retarding field, so that more and more gain can be achieved due to this particular reason. That is why this interaction is continuous, and that has been done with the help of slow wave structures. So the other important point in relation to TWT and piston is that the wave in TWT is a propagating wave. Wave in traveling wave tube amplifiers is a propagating wave, but in case of klystrons, it is not propagating wave. So it is present in the cavity only. And the third important point, in coupled cavity TWT, as I said, in case of a TWT which is a coupled cavity, in coupled cavity TWT, there is coupling effect. There is coupling effect between the cavities. So if you see, this is the important point one has to note down before we proceed our discussion in respect of the traveling wave tube amplifiers. So this coupling effect between the cavities will be there for TWTs, whereas for klystron, each cavity operates independently. So with this brief about the purpose of using traveling wave tube amplifier, what are its applications, what are the types, why do we use slow wave structures, what are the different slow wave structures. Now let us discuss about the constructional details and operation of very popular traveling wave tube amplifier, which is a helical traveling wave tube amplifier or helix traveling wave tube amplifier. So quickly see what are the constructional details. So we have cathode, it is being supplied with the regulated beam supply voltage. Then we have anodes, then we have a helical structure, helical slow wave structure inside the tube. Okay, and the RF input is given to this helical structure, and at the end of the tube, RF output has been taken out from the helical structure. At the last segment, we have a collector which is going to collect the electrons once they have given up their energy to the electromagnetic field. So the collector supply is given, which is a positive potential. Then gain or modulation control voltage knob is there, or if required, helix current, if high amount of current is flowing, that can be displayed on this overload relay, and that can be controlled with this particular voltage provision. Okay, apart from that, two important other blocks are also there, two important other entities are also there. One is a focusing magnets, as we have used them in case of multi cavity, and we have also used attenuators to be placed in amplifier. So this is very important, since we are talking about amplifier. What is role of this attenuator, that we will discuss. So once now we have understood what are the constructional details, let us start the operation. Let us start to understand how this TWTA is going to give a microwave signal amplification. So what happens when we give a beam supply voltage? We know that cathode will generate the electrons and they will travel with some velocity, which is velocity v0. We have done it many a times. It is 0.593 into 10 to the power 6 under root v0 meter per second. So this is the velocity of electrons with which they travel towards the helical slow wave structure. If they come to the helical slow wave structure, it is very much required that this velocity has to be slightly greater than the axial component velocity of the RF field. Because see what I mean, if you have been fed RF signal to this helical structure, because of the RF signal flowing through this helical structure, there will be the axial electric field generated because of that RF signal. So the velocity of electron beam is adjusted slightly greater than the axial electric field velocity along the tube. And why do we do that? Because if we have the velocity control using this v0, which is slightly greater than the axial electric field, and that is this v0, what will happen? There will be more electrons in the retarding field than that of in the accelerating field. So because of more number of electrons in retarding field, the more number of greater amount of energy will be transferred from that electron beam to the electromagnetic field. So that is the reason why we adjust the DC beam voltage in such a way that so the beam velocity, electron beam velocity, is slightly greater than the axial component of the field in the slow wave or on the slow wave structure or in the tube. So that is the first starting point. Once electrons moving inside the tube and there is an interaction with the RF wave, so we know the concept of acceleration and deceleration, that is the velocity modulation. Some electrons will travel with the unchanged velocity if they do interact with the zero amplitude of the RF signal. Some of them will increase their velocity and some of them will decelerate their velocity depending on the amplitude of the RF signal. So the velocity modulation process will be actually happening inside this particular tube, which we have discussed in our two cavity klystron article in detail. We have obtained the expression for velocity modulation, and if the electron beam and RF signal is continuously traveling down, there is the continuous process of velocity modulation and dense cluster of electrons is going to form, and at the end you will get the amplified version because more number of electrons will transfer their energy to the electromagnetic wave, and that amplified signal can be taken out from the end of the particular helical structure that we used to call it as RF output. So how exactly this amplification will be done, that I will just try to demonstrate with the help of the drawing. So at the start, see, the interaction between RF signal and an electromagnetic wave will be smaller one. So I will draw here itself. So it is something like that. This is an amplitude at the input, and if the interaction between RF signal and electron beam is uh, uh, increasing or improving through the length of the tube, so slowly electrons will give up their energy to the electromagnetic field, and the amplitude of electromagnetic wave will start to increase along the length of the tube. So as the improvement in the interaction between electron and RF beam is continuing, there is the increase in amplitude of the RF signal. But when you come to this particular point, you see there are attenuators have been placed. So they will attenuate this particular RF signal, and a very small signal will be allowed to go further to the right side towards RF output because of the attenuators are going to attenuate some signal. Then again, a very small signal will be there. Again, the process of electron beam and RF signal interaction, that is velocity modulation, and during retarding field, electrons will give up their kinetic energy in form of an electromagnetic energy to the RF wave, and again the process of amplification will be taken place, and at the output you will get the amplified RF signal. But what is the purpose of this attenuators being placed in between of this tube? Rather, they are not helping the operation of amplification. They have been reducing the strength of the signal along the traveling wave tube. So the most important use of this attenuator is that, because since at microwave impedance matching is very much important, if since this is a high gain amplifier, if at the output if there is impedance mismatch, and because of that if any signal is reflecting back, and if that signal reaches to the source, so they can disturb the source and they can make it means even this is an amplifier. If any reflections from load reaches to the source, this amplifier can start giving oscillations, so it could become an oscillator. So to avoid that, to stop any reflections which have been started because of the impedance mismatch from load, to stop them before reaching the source, we have placed attenuators after traveling some distance in between this particular tube. No doubt it is going to reduce the signal strength by a certain amount, but they are protecting this amplifier to keep it acting as an amplifier, and if any reflections will reach to the source, that amplifier may result into oscillations because the stability of that particular circuit would be disturbed. So that way these attenuators are placed. And finally, let us talk about these focusing magnets. So these focusing magnets, actually they produce an axial magnetic field, because bunching will improve as electrons move along the length of the tube, and more dense cluster of electron bunch would be formed. So to avoid any spreading of the electron beams, these focusing magnets are going to produce axial magnetic field, which actually prevent the spreading of electron beam. So that is all about the operation of traveling wave tube amplifier and purpose of all the elements which have been used in this particular amplifier. Thank you.